So we've decided to bring in one of the most interesting topics and speakers for this session to ensure that everybody is wide awake. And this is the opportunity to have the UK government talk through what is happening in the innovation effort on government side to support development and particularly the commercialization of clean energy technologies. And that's technology support, business models, systems. So we have 1 hour for this topic. First, I'd like to invite Damitha Adikaari to join me here, who is the Director for Science and Innovation at the Department for Energy Security and Net Zero. And Damitha, you've been at the department through several versions and name changes. And you're a fellow here at the IET, so if I may, welcome home, or you should be welcoming us. Would you just set the scene for us and tell us what is in the delivery plan for the innovation strategy? And some of that's the financial package, but of course it's the objectives and a little bit about the toolkit the government thinks it can bring to working with business in this space.
Great, thank you very much, Jesse, and thank you very much for inviting me to come and speak to you. Great to see you all, good to be here. So, yes, quite a lot has happened, especially over the last 3 months, and this is my 3rd department I'm working in, but I've been doing the same job effectively, about 4 different jobs at the same area. We are now energy security and net zero, as there's no short form for it. So what's the role of innovation when it comes to net zero? So if you followed, I'm sure you have, or the 30th of March announcements and the vast amount of information which was published, that kind of fulfills a number of requirements around the need to respond to the Climate Change Committee's report, the judicial review related to net zero strategy, as well as the Skidmore review. And that's the sort of main aspects that we tried to cover. And what it tries to set out is more clearly what the plan is to achieve carbon budgets on our way to net zero. So where does innovation sit in that? Innovation sits talking about a bit further into the carbon budgets, perhaps carbon budgets 5 and 6. Yes, there are impacts for carbon budget 4, for example, but at the same time, this is more around what needs to happen for us to be able to deliver those quantified carbon benefits. If you look at IEA's assessment, this is just a rule of a thumb thing where people say that 50% of technologies are not yet ready or commercially available to deliver what we need to deliver. You can debate about that, but what we can all agree is that there's quite a lot of innovation in technologies, processes, and way we do things need to happen if we are to deliver the carbon budgets. It's a very steep trajectory. So we try to fundamentally drive technologies, processes, and other aspects necessary to deliver those policies on an accelerated footing and try and increase the uptake of them as much as possible. Now, one of the reasons why there is a specific attempt here from an innovation perspective, because you could wonder, there is an innovation strategy for UK, and why won't we just rely on that and build on that? And our view is that the timeframes that we are working towards is too steep, so therefore there is a necessity to have a slightly different or a advanced or accelerated effort to minimize the barriers that we see. And we might also uncover different ways of doing things along the way, and that's where this sort of principle is coming from. Now, it's been a long journey, but at the same time, we've made quite a bit of progress. So if we just try and identify the innovation aspect of it, we did, after the 2015 spending review, put in place a structure called the Energy Innovation Board, which was chaired by the then Chief Scientific Advisor to the government. We have now, after the 2019 changes to legislation, made it a Net Zero Innovation Board. And then through that, we've set out a framework where all areas, as we could see, after extensive consultation, the innovation requirements are, and this includes quite a bit of research and development as well. So it looks at the whole chain of innovation through to the deployment end, not including deployment, but what needs to happen just before that. And that work was published in 2021, which sets out a good framework, which was well received, and is kind of a global first as well in a comprehensive sense, setting out what we ought to achieve. Along those sort of works, we also sort of negotiated and secured a number of funding avenues to do the work necessary. So the framework was looking towards 2030, but then in the near term, how UK's sort of funding structure works, depending on the spending review, so we had to even chunk it even closer in a near-term basis, and that's what the delivery plan that we published on 30th March sets out. So it's about just over £4 billion, 4.2 billion to be precise, over 3 years. And of course, there's about £300 million worth of investment going in from Ofgem, sort of consumer paid funding as well. All that is trying to set out from the framework which areas are being investigated and what money is invested where. There is some detail of what kind of outcomes we are trying to achieve from that as well, but some of them are nascent, some of them are a bit more formed, but that depends on the sectors. All 7 sectors are covered, and that sort of sets the framework, puts the plan in place, and relies on different departments and different organizations to deliver the value of that investment, the £4.2 billion of investment that we've identified for this SR. And there's more work to be done, and the expectation now is that, okay, what else do we need to pass on to from the pre-commercial stage, for example, some of the technologies, what needs to happen for private investment to come into play, and the uptake to accelerate as fast as possible. Some of the innovations might fail, but that's the whole part of the nature of innovation, and therefore the risk appetite for this portfolio of investment is high. But is that the right one is something that we are thinking about at the moment, and what else we ought to be doing in terms of next stage or handover is the other things that we are thinking about. And we are working very closely with British Business Bank as well as UK Investment Bank with their new remits around net zero, how we can accelerate that. In addition to that, we are also working with the private sector in terms of private funding. We work very closely with Gates Foundation, for example. Mm-hmm. Our own sort of contribution to breaking barriers is a clean growth fund where we were a cornerstone investor, which closed at £101 million and now invested in 7 projects, very quick succession. So quite a bit of progress, lots more to do.
In there, some very interesting and important concepts, some toleration for failure, which perhaps is not an easy conversation in government, but is an essential conversation in the innovation space. And I guess underpinning the whole process has been a very intense process of needs assessment and an ongoing needs assessment and learning by doing. We're going to hear about 3 projects that have been part of this program. But I'd like to ask you what the feedback and the sort of debriefing and the input to the next phase process will be as you look beyond 2025.
Yes, so we are already looking at what else we ought to be doing in terms of the analytical basis, understanding, trying to sort of take us through a whole systems perspective, what the solutions or what areas we want to expand on, focus more on, where our biggest impact would be. So you may have heard of Energy Innovation Needs Assessment, which was a sort of upgrade of the Technology Innovation Needs Assessment some time back. And we are now going out very quickly to refresh that and understand in a net zero context what else we ought to be doing. And that might tell a slightly different sort of portfolio of effort. It might be the same areas on 7 sectors, but slightly different focus perhaps. That work is happening. And also we are looking at working with the new government chief scientific advisor with Patrick Vallance, who's done a stellar job in helping us driving progress on this, and now no longer there. So there is a fair bit of work on that front. In addition to that, we are engaging the ministers as to what the next steps should be. And that the difference with net zero innovation is that that's done as a cross-government effort. So it's an HMG effort. It's not just the Energy Department or the Department for Transport or Department for Food and Rural Affairs. So there is this collective effort, which is what we need. Our expectation is that now that the overall investment portfolio is maturing, for example, the net zero innovation portfolio, which is £1 billion that I am personally responsible for, we are over £1 billion committed. That there is an associated advanced nuclear fund associated with it. That's why it's over £1 billion. But we are way into delivery, and now it's time to consolidate on what we've invested and also look to the future. But we shouldn't forget that it's not just government investment. There's quite a lot to happen and a huge role to play by the industry, which they are doing. But it is innovation. I always come back to the fact that it is uncertain. So therefore, we have to keep options open. And that's the focus at the moment.
Well, let's listen to 3 examples and then move into discussing some of the implications of that framework. And of course, we'll have some time for questions. So if I could invite first Matt to come up and speak about Supercritical.
First, to give you a bit of context of who we are and what we're doing. Is Chris still in the room? Can't see, but we are also a catalyst. So we talked about it earlier. We believe very strongly that we want to be a catalyst for sustainable life on Earth. So we are very mission driven about as a team who we hire, whether we've come from oil and gas or from sort of academia, we're all kind of very passionate and driven about what we're trying to do. We also believe that we can convert the existing hydrogen market from its fossil hydrogen to green hydrogen. So clean, affordable hydrogen is that transition to do that. That's almost 1 billion tonnes of carbon dioxide going into the atmosphere currently, and we can eliminate that one. That's a big prize to go after, converting that grey to green. We also believe that hydrogen is a perfect fit, if you can get it, clean and affordable, for 3 main sectors. So we think it's perfect for chemicals. So where you're using hydrogen as a molecule, using that and decarbonising that industry further. We also believe it's suitable for industrial heat. So industry is a sector, but it's the medium to high grade heat sectors where I think it really adds value. Anything that's kind of medium grade, it's kind of borderline, low grade heat, electrify. We've said it already, that is the right path and right direction for us to get to a sustainable planet. But that medium to high grade, that's where it's more interesting. We also believe that heavy and long distance transportation, that's where it can play a role. So personal transportation, I think batteries are still the right answer. Let's focus on the right technologies for the right sort of application. What we are developing is a new class of electrolyzer. So it's not alkaline PEM, solid oxide, it's a completely new class that we are developing in-house. This is very much the short version, so apologies, it's going to be a real sort of condensed sort of version of this one. Any electrolyzer, any development on electrolyzer has to be more efficient than any of the existing technology. Has to be. You're never going to get the cost down unless you get the efficiency up. We operate at a level of efficiency not seen by any existing class of technology. We also deliver pressurized gases, so over 200 bar natively without gas compressors. That's exactly what all those existing users of hydrogen need. So think ammonia. The Haber-Bosch process needs 200 bar. We output over 200 bar. It's a perfect fit, and you eliminate those gas compressors. We've developed something that is durable. It is membraneless. So all other electrolyzers, the first point of failure is the membrane. We've designed it to take out that point of failure. You don't get that cliff edge failure of a membrane failing. The metals we've selected, we've lent on very much from the nuclear industry based on our operating conditions to understand what metals are going to be durable, what is going to last far longer than any existing sort of technology. Because of our operating conditions, we're also able to operate on very high current densities. So we get a high hydrogen and oxygen output for a given amount of input, which means that you can shrink the footprint of your electrolyzer. All this lends itself to environmental sort of benefits as well. The all-metal design means that at end of life, you can figuratively pour it into a big melting pot and recover the industrial base metals it's made of. So end of life, you're able to sort of recycle very easily using existing technology. Because we operate at medium temperatures, so we're at 400 degrees C, we actually like heat. So on other electrolyzers, they have to cool the stack down and they use additional water. So environmentally, we don't need or want that. So we have no stack water cooling system, and therefore we don't use the water that other electrolyzers use and consume. We do not need or use iridium. So iridium is used in other electrolyzer classes and types. It is pretty much Earth's rarest element. We get more of it from meteorites, I believe, than we actually do from digging it out of the Earth's crust. That supply chain risk, it's not so much the cost, it's the supply chain risk. If we're going to reach our goals, we need to minimize and simplify that supply chain. Which brings me on to the last point, is we do not use any forever chemicals in our design. So other electrolyzer classes use forever chemicals in their membranes. Forever chemicals are not good. If we've eliminated them, we can simplify supply chain. We can actually make manufacturing easier. So our manufacturing process is all very industrial metal. So we can actually use existing tooling to make our electrolyzer all out of metal, which gives it a long durability. What you're hearing is we thought very long and hard and innovated around both supply chain, in life, and end of life. Bringing on to the project that's been alluded to, this is a nice use case again, whiskey. Not everyone likes whiskey, most people do I speak to. So whiskey projects, it fits into that industrial heat. It's kind of that medium grade heat. And whiskey, believe it or not, is incredibly energy intensive. It uses 7 times more energy to make whiskey than gin. But the world's not ready to just drink gin. So we need a decarbonized version of whiskey. So this project is 100% funded by the government. I'm very appreciative of that. But we're in collaboration with Beam Suntory, the 3rd largest distillery group in the world, working with both their Scottish operations and in Japan. So we're able to get a real good holistic global view from the distilling process. And working with MTC as well from a manufacturing capability. The objectives for us in this particular project is twofold. The first part is we are scaling our technology out of the lab. We're still a young startup, but getting large enough to escape the lab, go into an industrial setting. So again, sorry, northeast of England is where we're building this demonstrator. So wrong side of the country, clearly. But we are building it up there, escaping the lab. That moves us from TRL4 to TRL5. So that's scaling up and out. So it's a multi-cell arrangement in a full system to be able to demonstrate and invite people to. In fact, the government was the first people to come and view that a couple of weeks ago. The second thing we're doing is we're going to make some whiskey. So we're going to make some hydrogen-powered whiskey. And unlike a lot of conversations around decarbonisation, where you're just trying to fuel switch, take out the carbon out of the fuel and the energy you're using, we're going to do that, but we're also going to increase the quality of whiskey. And that's an unusual mix between the two. Not only are we going to decarbonise, the goal is to actually improve the quality of whiskey. And we're doing that because we're actually going to be directly firing underneath the still. This is how whiskey used to be made. We moved away from that when we actually moved away from coal and we went to indirect steam. But going back to a flame, a naked flame, directly underneath the still, we're bringing back traditional mechanisms without the same carbon emissions. I'm going to pause it there because otherwise I will just keep talking. So thank you very much.
Thank you.
I'm going to come at it from a slightly different perspective and talk about something that's working with a technology which is way beyond the TRLs. And I think if you look at this diagram here, you can see a classic TRL ladder, which everybody refers to. And then you can see what actually happens with real innovation on the right, which is commercial readiness index. And just about anything worthwhile gets an example out there, and the technology reaches TRL 9. Obviously, there's a number of things fall by the wayside, but by and large, anything that gets forward to TRL 9 obviously hasn't done. But that's just the first attempt. And then, certainly for long-lived assets, you keep developing them and developing them and developing, and you basically almost never stop developing them until you stop using the technology. And you not only develop ideas for when you build new plants, you actually put those innovations into the plants themselves. And for those of you in the power plant industry, perhaps you might remember when we upgraded to more efficient blading in turbines, and we had steam turbines that have been 30 years old in some cases, I think, and the blading was upgraded, and we got another extra few percent, 5% as much as efficiency out of turbines that were already damn near perfect at 90. And it just shows what can be done when you actually focus on where meaningful innovation to improve the commercial readiness index takes place. Now, I have to say, I think the UK has been absolutely awful at recognising this. The number of times I hear TRL, particularly from research councils, but even from other people in innovation, who know about industry, but really don't recognise as well as they should do where the real innovation takes place. Fortunately, I have to say, it is recognised in the BEIS now, DESNZ programme. This diagram actually is taken from Mission Innovation Advanced Capture Technologies brochure, pointing out that you need to do this. So just bear it in mind that what you're really after most of the time is taking something that is at TRL 9, raising up the commercial readiness index by doing low, effectively the sort of things you would do at low TRL, but without a valley of death. There's still a risk they may not be successful, but you don't build a prototype and try that out. You try them in a large-scale plant and find it doesn't work. So what did we do? Well, we are looking at classic amine post-combustion capture, which is a pretty significant part of global aspirations to capture CO2 at large scale. The diagram shows a very simple version of it. Do I have a laser? Yeah, I sort of have a laser. So you basically got a figure of 8. You put flue gas through an absorber and trickle solvent down, capture the CO2, take the solvent away, trickle it down against a flow of steam that you're producing in a reboiler at the bottom. That releases the CO2. Flue gas goes on without the CO2. And ideally, you'd like to get the CO2 concentration in that flue gas down to the CO2 in the air coming in, say 400 parts per million. So you're almost, in a sense, doing air capture levels. And that's perfectly feasible if you take some care. So what we saw in this program it came out of a high capture level study that we did with AECOM, again funded by BEIS it was then, looking at how you capture full amounts of CO2 all the time. What we did was to look at how you drive this bit efficiently. And the way you do it is, obviously, you condense as much of the steam as you reasonably can that you're producing in this boiler at the bottom before it gets to the top. And what we're looking at here, come and see me afterwards if you really want to understand it, is a range of temperature profiles, and it's a bit like Goldilocks. You've got a lot of profiles where you condense the steam too soon. And it means that you're not making that unit work hard enough, and you're not squeezing out as much of the CO2 from the solvent as you can. In turn, the solvent then doesn't want to grab the CO2 as sort of aggressively from the flue gases, so you can't get the CO2 concentration down. You go here, the high level, and you're producing a solvent that's very aggressive, but you're wasting a lot of steam. And that means you've got very high energy. And then there's a few in the middle where you're getting it lean and you're also not using too much energy. But you've got to know what you're doing to hit that condition. The two graphs look the same, but one is computer modeling, and the other one, which was produced afterwards when we knew what we were looking for, is from trials of the 10-ton-a-day unit in Birmingham, Alabama, in the US. We're collaborating with US DOE on this. You then have to use it effectively in the absorber. You have to get exactly the right flow. And again, people haven't been doing that because they didn't know they need to be so precise. The other part of it we're looking at, and this is a picture from the study that was done with AECOM a few years ago, is to look at how do you make sure you can capture solvent all the time when you're starting and stopping. When a power plant starts for a while, it's not producing the steam you would need to do this boiling off, and so you have to do something to make sure that the absorber gets solvent. And what do you do? Well, the simplest thing is you put in a big tank of solvent at the top and a big tank to take the solvent at the bottom, and for as long as you don't get steam, you run the solvent through. And I have to say my proudest moment was when the chief engineer of a major oil company said, "Oh, this is agricultural technology, it's bound to work." Yes, sir. That's the whole idea. And so we're doing this work. It's perfectly open because we're not using a magic solvent that nobody will tell you anything about. We're just using good old MEA, which, by the way, is pretty good because you can reclaim it. And we've developed the concepts, we've done the modelling, we've got some preliminary work, and our next job is to take this 1 ton a day unit at Sheffield and add some solvent storage in here and prove the control concept and see that it actually works when you're running different imaginary profiles, matching different power plant activities. So thanks very much, and thank you for particularly supporting something which is obviously applicable to technology that's well beyond TRL 9, but is nowhere near commercially mature.
So my name is Rob, and I work for an organisation called Glass Futures. I think Glass Futures is a really exciting initiative, and it's a great example of how government and industry have worked together to provide a platform to deliver some of these disruptive technologies that are needed to achieve the net zero industry that we want to achieve by 2050. So I mean, I guess in terms of, for those of you who haven't heard of Glass Futures, we were basically born out of a need within the glass industry to have a platform to develop and demonstrate and de-risk technologies at a pre-industrial scale before actually putting them onto an actual glass plant. For anyone not familiar with glass manufacturing, basically at the heart of a glass manufacturing site is a massive furnace. The furnace has to operate at temperatures of around 1600 degrees, 24/7 for up to 20 years without stopping. It can produce typically anything from 400 tonnes to 1,000 tonnes of glass per day, and also the glass comes straight out of the furnace, has to be formed into the final product. So you have to get it right first time, every time, for 24/7 for 20 years. So you can appreciate why the glass industry is rather reluctant to try any technologies that aren't quite tested or proven, because if you disrupt that process, it can take weeks to get any defects out of the furnace, and it'll cost millions of pounds. Plants also typically only have 1 or 2 furnaces on site as well. So massive risk. There was a need to demonstrate these disruptive technologies in order for the industry to adopt them. So that was where Glass Futures came from. And it's been a great success because basically industry came to government and said, look, there's a need here. We need some funding to get it going. If we get the funding there, industry will then step in and continue supporting it. So we've had to date about 30 million pounds of funding from government, and that is now attracting industry funding to continue these developments. We've also managed to create a global platform as well. So it's a UK-based initiative initially. It's had a lot of UK-based funding. But actually, if you look at our membership, so we're actually a not-for-profit membership organisation. And across our membership, we've got several manufacturers who have glass plants all around the world. We cover all the different glass sectors as well. So it's not just containers and float, which are the 2 biggest ones. We've got the likes of Corning as well, who are also interested. So this is like a multi-billion-pound company based in the US. You've probably heard of Gorilla Glass that they make. It's on most mobile phone screens. But they've come to work with an entity in the UK because there's nothing else like this in the world that allows them to develop some of these technologies. So what we've developed here really is exciting, and it is a globally unique facility. At the heart of what we're doing is we're developing a pilot facility. So this is a building that has just been constructed in St Helens, just outside of Liverpool. And the idea is that whilst it's like a small glass production line, so it produces 30 tonnes per day, so quite a bit smaller than a commercial plant, but it's at a scale whereby the results we get from this line can be upscaled and translated to a commercial plant. And what we've done is we've worked with industry, so we've actually worked with the furnace designers from many of these international glass manufacturers to design a furnace whereby they can bolt on all the different technologies that they want to develop so that they can prove them, and they have the confidence that if they prove it on this facility, then it will work on theirs, or at least they can upscale it using models. So in terms of some of the technologies we've got, we've designed it so it can look at a whole range of different fuels, so obviously hydrogen, but also biofuels. So it'll be able to look at different liquid biofuels, but we've also designed it so it can be upgraded to look at things like simulated syngas, biomethane, and also hybrid scenarios as well. So we can look at electric melting while firing with hydrogen and biofuels, all at the same time to work out really what's the best combination of different fuels for a given plant, making a given product in a different given part of the world. Also, the facility is designed to be able to bolt on other technologies. So we've designed it so the sort of flue gas end, we can actually pass some of the exhaust and divert it into, say, a carbon capture system or a waste heat recovery system. So we've actively got a few projects looking at some of those technologies already. And then also, it's just a test bed where maybe universities can come. They might be developing a new type of sensor, imaging system, new coating technology. So again, they can come along. It's totally open access. They can trial their technologies at our plant. So this is just a picture of what it looks like. So you can see on the left there, at the bottom, that's our new facility. So it's pretty big. At the top there, you can see the Saints Rugby League ground. So you can see it's a comparable size. Top right-hand corner, that's what the building looks like now. That was taken a few weeks ago. So the building itself is finished. We're now fitting it out with this small-scale furnace, which you can see a little schematic of in the bottom right-hand corner. So all being well, this time next year, that site will be producing glass. It will be testing new technologies. The other thing to mention is we're not just all about this 30-tonne per day furnace. We realise that actually some of these disruptive technologies will require other developments, other bits of kit. So actually over the last 2 or 3 years, again with a lot of help from government and government funded projects through schemes like the Industrial Fuel Switching Scheme, we've actually developed a combustion test bed, multi-fuel combustion test bed that's currently actually based at Steelworks in Rotherham. So this has been used to trial and benchmark hydrogen technologies and various biofuel technologies against natural gas. So we've looked at things like heat transfer, the impact of these different fuels on emissions, and efficiency of the process as well. So you can see like a little nice infrared image there at the bottom. But then what we also realised is once we developed the asset, we were actually approached by some of the manufacturers in the ceramic sector, and they said, well, could you actually use this asset to do some hydrogen firing trials of different ceramics? Because we've got people in the ceramics industry that also want to explore hydrogen. So again, with government funding, under another industrial fuel switching phase 1 study last year, we were able to modify the rig, and we actually did some of what we believe are some of the first 100% hydrogen-fired trials for some of these kind of commercial ceramic products that you can see there. It's a project led by the British Ceramics Confederation with 12 partners, and they're all very keen to continue doing this work going forwards as well. And then off the back of that, we then got approached by some of the local steel manufacturers in Sheffield. So this was a bit of work that was funded under the Industrial Hydrogen Accelerator scheme. So this is a project that was done at the back end of last year. So again, we fired a number of steel products from different organisations like Forge Masters, just to see if you're firing these products under a hydrogen atmosphere, 100% hydrogen atmosphere, does it actually affect the metallurgy and the product quality? So again, we were able to really reproduce some of those heat treatment profiles that they have in their current furnaces, and we're able to help them demonstrate that actually you can fire those products on hydrogen without affecting the metallurgy. So that's just a little bit of a flavour. I could go on all afternoon, but I'll stop there. Thank you very much.
There's a lot going on. Let me then pose an important question, which is, how do you find the time for some of the wider knowledge sharing from these different approaches to innovation, the different lessons you're learning, the gaps you're identifying, the nature of the partnership between government and business? How do you find time to think about that, discuss it, share insights, on top of the work that you're doing? Any takers from the panel? John?
Yeah, so, well, it's part of my job because I'm director of the UK CCS Research Community Network. And you know, as it says, the name on the tin, we're there to network research with industry. And a bit of a plug, we're having our first, by name, Knowledge Exchange Conference in Sheffield at the start of September. And we're able to do that now. I mean, it's interesting when you say share with industry. You've got to have industry there to share with. And we've been running for, well, nearly 20 years in various forms. And industry, I'm afraid, comes and goes. You know, and it's a bit like the sea coming in. It comes in a bit further each time. And now we're really about to sort of knock over the sandcastles or whatever the analogy is.
And
There's
Rob's
a
got
big wave.
industry coming to a facility he hasn't finished building yet. So yes.
Yeah, but we've got people there to listen. So I think you can do it quite easily if you've got the setup, and I can't see Karis, but our network manager, his network manager is there. And we're used to running big conferences, but unfortunately, up till now, there's been a preponderance of academics. But clearly now there's so many more people in the business, I think we will start seeing actually more industry and people there learning, and that's what we're there to do. So the first thing is how you do it is get some people to listen. Because you've got to be actually thinking about it a bit yourself before you can understand what anybody's telling you if they're telling you something detailed. And then the other thing is I've found if you look on my LinkedIn page, you'll see this stuff. That's where I based it. So actually, these days, you can tell, if you want to tell people what you're doing, you can tell quite a lot of people what you're doing very, very quickly and very, very easily, anytime you like.
Damitha, how do your team deal with being able to go to all the facilities, listen at all the conferences, gather the knowledge, and still do their day jobs?
So they do attempt to do the best they can, but I don't think we are doing enough. So I just wanted to expand that though. Dissemination and learning from each other is really important, especially because we don't have any time to lose. And one of the metrics I use is that we've got just over 1,400 weeks to 2050. So that's not a long time. So we are not doing enough in terms of disseminating and learning from what's happening. And that's an occupational hazard as well, because we've been trying so hard to stand some of these programs up. And when I first joined DEC in 2012, our portfolio was about a couple of £100 million. And now we're talking in billions. So that work is done by these guys and people around in the audience. So there's a lot of learning coming through. We do track them. So we have a good understanding of what level of innovation is happening, how the dreaded TRL scale is advanced. You have to have some sort of a metric, John. So,
commercial readiness, as I say, the commercial readiness index concept, which was brought in for renewables, I think it's very powerful, and it formalises that, as I say, there's a whole development process. That's not to say you don't do low TRL work, and great from the glass futures, just how it goes. Yeah, but you're at one particular stage, and if you get your technology into service, then people will probably carry on improving it. I'd be very surprised if they can't do. And it just happens that naturally, given that we've got to actually do something, there's technology out there which is at TRL 9. And if you say, oh, we don't fund TRL 9 work related to TRL 9, give it to industry, but yet it's a market failure and it's not something that industry can justify funding themselves, then it doesn't happen.
I've got two more takers here.
Sorry.
I'll finish very quickly. So I agree with John on sort of previously the sort of dynamics are different, and now through this work and the sort of constant effort in expediting work, there is a community forming, and we see that all the time. And my colleagues who are in the audience are also working up different ways of engaging. So at the same time, you have to have material, impactful knowledge to share.
Yes.
Just having conferences is not going to advance anything unless you can make something out of it. So that's we are quite conscious about that as well. And we, again, work across the government. We work very closely with UKRI in terms of a public investment perspective. But the thing I'm thinking about is that there are more learning to be had from the industry who are actually doing the work. They know how to do things. We don't do anything. We just provide the framework. It's the industry who's delivering the work. That's why I say that we are not doing enough, and we need to work more on sort of creating forums and engaging them more, and perhaps to open up a little bit more compared to what it used to be from a commercial confidentiality point of view.
Absolutely, and if we do get on pace, that will be an exponential, Okay, Rob.
So I guess to follow what's already been said, I would say, I think the key thing is that networking element. So no one's ever going to know everything, but most people could probably find out someone who does. I think this is why I found some of the government-funded projects so good, because they actually force you to build into a project like a dissemination plan, an engagement plan. So it's not just a case of you've got to find a way of squeezing it in. Actually, you're encouraged. Part of it is there to pay people to do stuff, to attend conferences like this, to promote what you're doing, to build the networks, so that when you do have a question and it's like, oh, I need to understand what's the latest in carbon capture technologies because one of the glass manufacturers has come to us. Well, I've got a list of people I can then talk to or put them in contact with to get that knowledge. So I think that's it. And I think also linked with that is promotion as well. So coming to this, saying what we're doing, actually people then come to us to say, well, how this is what we're doing, is this useful, or ask those questions. And I think this is where organisations like Glass Futures could be sort of maybe strengthened even more is sort of people coming. So if, for example, there's a supplier that wants to demonstrate a technology or wants to know who in glass or ceramics they need to talk to work with to get their technology developed, hopefully they could come to someone like Glass Futures or equivalent research organisations, and we can then link them with the best people, not just someone in the organisation, but the actual person, say, who is working on the furnace, who would be the best person for them to talk to. And likewise, in the glass manufacturer might want to, say, find out what's the best carbon capture technology, who to talk to. Again, they can come to someone like Glass Futures. We can then say, oh, look, these are the 3 companies we think are best suited to your process that we think you should talk to.
And you're set up to create networks, and with a mission in the knowledge sharing space now, perhaps the sharing of commercial knowledge in the direction of intellectual property that Damitha hinted at. Matt, I mean, I think you might want to come on that.
Yeah, just slightly different. So we can't do what we do on our own.
Yeah.
You know, we're a young, small, as capable and intelligent as the team is, and they are, and some of them are in the audience today, the best team I've ever worked with in terms of bright minds. We still can't do it on our own. So part of dissemination, and in a slightly different way, is actually working with partners. And so we work with some great partners now, and I'm opening this up. You know, we want to work with people. We know that we will not achieve our goals exclusively on our own. And so those partnerships and ways of solving problems, as you kind of indicated, but we want to actively do it as part of the development, not as an afterthought of dissemination.
Mm-hmm. I want to see if there are any audience questions, because this is a really hot topic. So please do give us just your name and where you're from, as well as your question.
Rahul Shivaram, so I'm from Deep Science Ventures. Basically I had a question. I mean, I'm quite interested in this idea, just going back to Damitha's point, about, so firstly, I mean, you're addressing risk appetite as a group of innovators and government absorbing a lot of risk by funding these early stage projects. And then the sort of industry who earlier I think we're referring to, the project needs to be profitable and it needs to make sense, you know, from a business perspective, which, you know, almost indicates that there is, you know, effectively not much risk there in that sense, because it makes sense on paper immediately. So I'm wondering, like, do you, I suppose 2-part question, do you perceive there, to maybe there being a shortfall in risk appetite from industry who are doing the work, let's say, as you said, and if there is that shortfall in risk appetite to bridge the government absorbing all that risk and industry picking up the operations, how do you bridge those two for first-of-a-kind technologies to allow industry to take on more risk and invest earlier? Mm-hmm. So.
Let's take an answer to that.
Or maybe, yeah, for everyone.
A couple of takers there, but Damitha first, of course.
Yeah, thank you. Risk appetite is an important point, and that's the reason why for example, if you take the net zero innovation portfolios, we do different mechanisms to fund things. Sometimes we go out to competition on a match fund basis. Sometimes we fund 100%, and that's a judgment on risk. Now, if I understood your question correctly, your question is that is there a gap in a risk appetite from the industry perspective to come up with doing things quickly, differently, new ideas? Now, I don't see that. And yes, we are now seeing that we can fund most of the good projects which are coming through the competitions. It wasn't the case some time back. So we still see very good proposals coming through, and we are not funding all of them. So there is a sort of opportunity. There is a question around additionality, and that risk appetite can be sort of discussed in a sort of isolated way. So there is a relationship to additionality. So therefore, you have to sort of take it in the round at that decision when you design a competition from our perspective that you won't see. We do consider some of these aspects. But having said that, some sectors, perhaps there are opportunities, especially the nascent sector, new sector. So we all now hear quite a bit about, greenhouse gas removals, but that's after the 1.5 degree report phenomenon. And before that, people knew that as a concept, but didn't talk about it.
Yeah.
And over 3 years or so, there is a sort of fledgling industry coming through. But when we go out, we see only a limited amount of ideas, and I can feel that there could be opportunity there. It's something like what you are doing. What we are doing there is that structuring the support in such a way that, as John said earlier, that the earlier sort of discovery phase type work is also supported. We are not forgetting that. But at the same time, trying to sort of handhold a little bit more. For example, my own program has an incubation support service where industry get little bit of support to advance their technologies very, very quickly. So we built in mechanisms, and the question is that at the right scale? And that's the bit that we are working on at the moment.
Rob.
Yes, I think I'd add to that. So I think my experience over the last sort of 2 or 3 years of working with Glass Futures has actually been really encouraging in terms of just seeing the desire of industry to take on risk. I think, as was sort of mentioned earlier on today, actually there's probably a bigger risk of not doing anything, and I think the industry now is realising, yes, there's risks involved in developing new technologies and trialling them, but the risk of not doing anything is bigger. So there's the appetite there, and I think also if you look at, for example, glass containers, it's not just sort of that environmental risk. If they don't become sustainable, their customers will go to other materials, so there's an existential risk as well. So I think the industry is really keen to trial technologies, and we've seen it. So, I mean, NSG, I think Paul's got a presentation tomorrow talking about some of their developments. They've looked at hydrogen, looking at carbon capture, new raw materials. So there's the desire from industry to do that. The challenge is that obviously glass is a global commodity. It's got to compete with different cost centres around the world. Many of the manufacturers have plants in every continent around the world. They'll have dozens of plants. So it's like, well, they'll kind of gravitate towards the lowest cost basis. So I think that, and this is sort of where government in the UK comes in, it's like, how can government sort of help and support industry in the UK to take that risk whilst not then putting them at an economic disadvantage compared to other global centres around the world? And I think and certainly what I've seen in terms of the different funding schemes, from the kind of early stage up to the kind of TRL9 for like the Industrial Energy Transformation Fund, there's a really good mix there, and I think it's just a case of then developing and evolving that as our kind of energy climate changes over time as well.
Do we have more audience questions?
Probably building on these two comments, I was wondering, what is the role of the UK government? I understand it's more kind of seed investment at some point to get all these ventures off the ground and start testing some of the ideas. How do you foresee, or what's the plan when hopefully some of these ventures start growing and they need to raise capital? Do you build also an ecosystem with VC funds? Because probably sometimes it feels like the leap into the industry is quite a big one. So some companies do have a CVC arm, but not all of them. You need to be large enough. So how do you help bridge that gap from a government perspective, and also the view from the entrepreneurs, how you see that? Thank you.
Thank you. So it's good point. As I mentioned earlier, so there are a number of mechanisms where we are attempting to do that. Now, obviously, investment alone from a technological advancement point of view and taking through whatever the scale you want is one side of it. Sometimes you don't need any support for the industry to sort of run with it. All you need is a proper workable business model. And that's a policy question. And if you look at some of the works that we have been doing over the past 3 years on hydrogen or CCS, and that is precisely to try and crack that problem as much as we can. If we leave that sort of bigger sort of deployment-related support structure, some technologies, some processes, some areas, you will need some sort of patient capital or high-risk investment. And this is where I mentioned some examples around Clean Growth Fund, which is something that we've funded, part-funded. And what I mentioned about the remit for the British Business Bank as well as the UK Investment Bank, where there is a net zero consideration now to be made. Mm-hmm. And there is sufficient funding in that sense, but they need to materialize. And this is where sort of the tables turn a little bit. So one of the things that we see, my portfolio of projects that I am looking after is close to 500. And there are some very promising, fast-moving, greatly achieving ones. And there are quite a lot of struggling ones too. It is related to the risk question. But if some of those struggling areas are the most important, then we've got a problem. So that's where we need to have more sort of bespoke interventions and effort. We are alive to that, but it all depends on what can be done.
Anyone else? Okay, John. Briefly.
Yeah, I mean, I still don't think we're differentiating clearly enough between innovation that's bringing stuff that's really completely new and stuff that's actually improving the commercial readiness index on existing products. And I think when you said the industry want to come and try out this, that and the other, I think most of the things you were talking about were components that were innovative and to some extent transformational, but nonetheless you could put them on something you already had.
Yeah.
And that's a really very fundamental difference. And I do think you need, maybe your budget doesn't cover deployment, but the UK at the moment is doing some incredible support, really, for projects making the final step on TRL or one of the earlier steps on commercial readiness index up to scale by taking a risk on 8 projects, and I think 8 capture projects. And I think it's probably fair to say that every one of those is first of a kind at that scale. I think they all are. But people are being quite cautious on those, and they're being cautious for 2 reasons. One is, they're the thick end of £1 billion each, probably. Government needs to support them because nobody can assess the risks of them. That's always the way with a first-of-a-kind project. There is no reference plant list to work on. And then also, apart from that commercial risk, there's actually a big risk for the future of CCS in the UK. So how many of those projects do you think could have serious problems? And we have seen serious problems in CCS deployment. I don't know, those of you who know Kemper County was turned from 2 billion to 5 billion and never produced anything. And, there's other projects that aren't running. I mean, so you say by all means take risks, but there's times when it's not good to take risks. And actually, I think it is the bulk of innovation really doesn't involve that sort of risk. It involves doing things that add on, and there's a different risk profile. But that is really where most of the money gets spent, and probably where even more of the benefit comes in.
Yeah, okay. Spectrum from optimization, which is one end of innovation, through to some of your perhaps strugglers, Damitha, but who might have breakthroughs that are still worth waiting for and hoping for. Okay.
I'll make just a quick observation, just in terms of the question here. So from a startup perspective and angle, I think the CVC money, it does exist. That's our first investor was actually CVC side. That was very early, maximum risk. They're basically investing in a team really at that sort of stage. So that was fine. That was doable. They had the risk appetite. They could get in that very, very early stage. If I jump forward quite a bit of time and you go to like pilots, so we're still not commercial scale, but we're still trying to test and just go bigger and bigger and bigger. There's actually probably corporates or VCs or even banks potentially who could start getting involved at that sort of stage. There's still a risk conversation, but it's the 2 ends. Where the government really comes in is transitions on every single step through there, because you've got to show that you've made progress. You've got to hit your milestones to justify to that next sort of level of investor that you've got there. And that's the risk that no one else seems to be willing to take.
And if the government has shown confidence in you at that transition moment, that's going to make the other conversations
100%.
a lot easier. Okay. This is a panel that could go on for a long time, but I think we're out of time. We have to send some of the panelists back to other parts of their day. Thank you very much to you all. Round of applause, please.